In this unit, we will discuss the concepts of momentum and impulse. You may have learned that momentum is equal to the mass of an object times its velocity. You may also have learned that if there are no external forces acting on an object, then momentum is conserved. In other words, if an object is at rest, it will remain at rest, and if an object is moving with a certain amount of momentum, it will keep moving and its momentum will be constant. If external forces are applied to an object, there is a change in momentum, however. We call this change in momentum impulse. There are several different ways to understand impulse. One of the most common definitions for impulse is impulse I is equal to the average force times delta t. Another way to think about this is I is equal to m times delta v, where v is velocity. Notice that these two equations really are the same. We know that F equals ma, so a force times a time is equal to a mass times a velocity. And finally, since impulse is a change in momentum, we can say I is equal to delta rho, or just change in momentum. Here's an example to better understand how impulse works in collisions. If you take two eggs and throw them one at a wall and one at a bed sheet, and you assume that they both have the same velocity to start and they both end with zero velocity, which one has more impulse? This is actually a trick question. They have the same impulse. Since both have the same change in velocity, both objects have the same change in momentum, thus the same impulse. However, there is an important distinction to make between these two collisions. When the egg collides with the wall exerts a large force on the egg over a super short amount of time. We know that I is equal to the average force times delta t. So in the case where the egg is thrown at the bed, the sheet does not exert much of a force on the egg, but this collision is much slower. It turns out that in both cases, the larger force with the quicker time is equal to the smaller force with the longer collision time, giving both collisions an equal amount of impulse. Next, we're going to talk about types of collisions. There are two main categories of collisions. The first is called an elastic collision. Both energy and momentum are conserved in an elastic collision. An example of an elastic collision is a ball bouncing off the ground back to the same height it started at. In this case, energy is conserved. The potential energy initially is equal to the potential energy finally, because the gravitational constant is the same, the mass is the same, and the final and initial height is the same. So mgh initial is equal to mgh final. The second is an inelastic collision. This is a collision where momentum is conserved but energy is not. We call a collision perfectly inelastic if the two colliding objects stick together after the collision. Going back to our old example, when the egg strikes the wall, it sticks and the two become one. This collision is perfectly inelastic. However, not all collisions are perfectly inelastic. Internal friction can act and cause a collision system to lose energy due to internal vibrations, a heating effect, and deformation, things like that. Note that in all three cases, elastic, inelastic, and perfectly inelastic, the total momentum of the system is conserved. In the next video, we will go over some practice problems to implement these concepts.